This is section 7.2, addition and subtraction formulas for trig functions. So first you start off with a whole list of trig functions. They are on your deck, so you should know them. Just a little FYI. Addition and subtraction, the double angles, the formulas that we'll do over the next few sections. There are questions on the final exam about these. I'm not going to tell you specifically which ones are on it, but that you should, basically all of chapter 7 is somewhere on your final exam, just so you know. So if we come down here and we want to find the exact values of this expression, which means you cannot type it in a calculator, you actually have to use these addition and subtraction formulas. If I'm looking at cosine 15, I want to think of two numbers that I know exact values for, are 30, 45, 60, 90, 0, and so on. Two of those values where I can get 15, either adding to get to 15 or subtracting to get to 15. I know cosine of 45 minus 30 is 15. 45 minus 30 is 15, so I'll use that one. So using this subtraction formula is cosine 45 cosine 30 plus sine 45 sine 30. All you have to do is actually plug in the angle measures that you want for the s and the t up above. Cosine 45 is radical 2 over 2. Cosine 30 is radical 3 over 2 plus sine 45 radical 2 over 2 sine 30 1/2. First we get square root 6 over 2 plus square root 2 over, oh, it's not over 2. What am I thinking? It's over 4. Radical 6 over 4 plus radical 2 over 4. We cannot add the square root 6 plus square root 2 because they are different radicals, so you just put it together as a fraction. Radical 6 plus radical 2 all over 4. If they are not common denominators, get them so they are common denominators and then combine. So sine of 75. 75 could be 45 plus 30. So I'm going to erase a little bit of this. So hopefully you got that. So using the summation formula from up above, the addition formula, sine 45 cosine 30 plus cosine 45 sine 30. And then we just got to write the exact values. Sine 45 is radical 2 over 2. Cosine 30 is radical 3 over 2. Cosine 45 radical 2 over 2. And sine 30 is 1/2. And again, if you notice, we get the same exact answer. This is square root 6 plus square root 2 all over 4. The next example is actually going backwards. Seeing this function, sine, cosine, plus, cosine, sine, you have to be able to see that and then go back and pick out which formula it actually is. This is the sine addition formula. So we're looking at the sine of 10 plus 50. Well, 10 plus 50 is 60. And sine of 60 is the square root 3 over 2. So remember, if they say exact values, or I, or whoever it may be, make sure that you are not giving me any sort of decimal. Keep them fractions, even 1/2, keep it a fraction. This one's we're actually using the subtraction formula to prove an identity. So I'm going to draw my line, decide which side is harder. The left side is harder. So I'm going to expand that out using the cosine subtraction formula. So cosine 3 pi over 2 cosine t plus sine 3 pi over 2 sine t. Well, cosine of 3 pi over 2. Pi over 2 is 90. Times it by 3, and you get 270. So cosine of 270 is 0 times cosine t plus sine of 270 is -1 times sine t. Well, this whole first part, that's going to be equal to 0. And this is going to equal to negative sine t. 0 minus sine t is negative sine t. Check. We're all set. Again, now we're going to use the subtraction formula for tan to prove an identity. So we're going to expand the left side using the tan subtraction formula, which is tan pi over 4 minus tan x over 1 plus tan pi over 4 tan x. Well, pi over 4 is 45 degrees, and tan of 45 degrees is just 1. So we get 1 minus tan x on top over 1 plus, and again here, tan 45 is 1, so it's just tan x on the bottom. And they match. Perfect. Oops. Wrong button. All right. This is the difference quotient that has come up every now and then. Are we ready? So I want to show that using the difference quotient, it's going to equal this function at the end, given that our function is just sine x. So I'm going to plug sine x plus h minus sine x all over h. Now that looks really simple, doesn't it? Except for the fact that sine x plus h now needs to expand using the addition formula. So sine x cosine h plus cosine x sine h, and then minus sine x at the end, all over h. Okay, well the first term and the last term both have a sine x, so I'm going to actually like regroup them so that those two are next to each other. So sine x cosine h minus sine x. And then I'm going to add that one at the end, cosine x sine h at the end. So since those first two terms have sine x in them, I'm going to factor out sine x just out of the first two terms. So I'm going to move over here to the right. So if I factor out sine x just out of those first two terms, I am left with cosine h minus 1. I'm not going to touch the third term. That third term is going to stay. Cosine x sine h all over h. Okay, well we're almost there. The only difference is that we split up that fraction. We didn't. So I'm going to actually split up the fraction with the two terms. So sine x, and they have cosine h minus 1 over h plus cosine x, oops, sorry about that, sine h all over h. There's a sine h over h at the end. All right, sums of sines and cosines. Here we actually, it's just literally got to plug in pieces. These two things equal each other. A sine x plus b cosine x equals this function right here. The k you get right here by solving it that. And the theta, you can get it from one of two ways. Using sine or cosine, it just depends on whatever you want to use. It really doesn't matter. So we're going to express, let me leave that up there. Express 12 sine x, 5 cosine x in that form. Okay, so A is 12, B is 5. So I need k. To get k, it's equal to the square root of 12 squared plus 5 squared. 12 squared is 144, 5 squared is 25. You add them, you get the square root of 169, which is 13. And then we need to actually have theta, which I'll just choose cosine. To get theta, well, let me write cosine theta. It's A, which is 12, over the bottom is essentially k, which is 13. If you actually hit second cosine, get our cosine of 12/13, theta is 22.6. So written in that form, you get 13 sine x plus 22.6. Last question. All right, so we have this function here, right there, Our A is radical 2. Our B is radical 2. I need to get K. So K is equal to the square root of radical 2 squared plus radical 2 squared. So the inside of that just becomes 4. Square root of 4 is our 2. Then we need theta. So cosine theta is equal to A, which is radical 2, over our K, which is 2. Well, 1 is cosine radical 2 over 2, 45. So theta is equal to 45. So written out in this function, we get 2 sine 2x plus 45. Very good so far. Okay, so now it talks about actually graphing in the phase shift. We're not going to graph it, but at least let's pick out the amplitude, the period, and the phase shift. The amplitude is easy, right? It's just the 2. That 2 is the amplitude. All right, to get the period, you actually have to take what the function is, like sine of actually 2x plus 45. If you don't remember, set it equal to 0 and set it equal to 360. That's a 360. Pretend that says 360. So you move 45 over, divide by 2. X is now negative 22.5. If you move 45 over, divide by 2. 315 divided by 2. I do not know that off the top of my head. So 315 divide 2. 157.5. Okay, so to get the period is the difference between those two. 157.5 minus negative 22.5. The period is 180 degrees. The phase shift is actually this part right here, right there, where normally sine curve starts at 0. Well, we're actually not. We're starting at negative 22.5 degrees to the left. So our phase shift is 22.5 to the left, since it went back to negative 22.5. And there you have section 7 too.